discuss the different CPUs available in the operating system.
Now, we have here the first come first serve algorithm. The first come first serve algorithm is the easiest algorithm among all. Why? Because there is no preemption happening. In here, we have 5 processes named P1, P2, P3, P4, and P5. P1 has an arrival time of 0 and a burst time of 8. P2 has an arrival time of 3 and a burst time of 4. P3 has an arrival time of 4 and a burst time of 5. P4 has an arrival time of 6 and a burst time of 3. P5 has an arrival time of 10 and a burst time of 2. In first come first serve algorithm, there is no preemption happening. The first process to come to the ready queue is the first process to run, execute, and to be finished. In our process, as you can see, P1 arrived at time 0, so it will be the first one to come on the ready queue and the first one to be executed and to be finished. We're gonna put P1 on the ready queue with a burst time of 8, and we're gonna put it on the Gantt chart to illustrate it. So P1 starts at time 0 and finish at time 8. Within time 8, 3 processes arrive, which is P2, P3, and P4. So we're gonna put it on the red queue. So within the 3 processes, P2 has an arrival time of 3, so it will be executed next. So P2 has a starting time of 8 and it will be finished at time 12. So at time 12, P5 has arrived with a burst time of 2. So the next process to be executed is P3 with a burst time of 4. So P3 starts at time 12 and finish at time 17. The next process is P4. It starts at time 17 and will finish at time 20. The last process is P5, which starts at time 20 and ends at time 22. Now, we're going to compute the average waiting time and average turnaround time of these processes. The formula for average waiting time is starting time minus arrival time. So we're gonna write the processes first. So P1 starts at time 0 minus its arrival time, which is also 0. P2 starts at time 8 minus its arrival time of 3. P3 starts at time 12 minus its arrival time of 4. P4 starts at time 17 minus its arrival time of 6. P5 starts at 20 I mean, minus its arrival time of 10. So 0 minus 0 is equals to 0. 8 minus 3 is equals to 5. 12 minus 4 is equals to 8. 17 minus 6 is equals to 11. 20 minus 10 is equals to 10. So we're gonna get its waiting time or average waiting time. So its total is 34 divided by the number of process, which is 5. So our average waiting time is 6.8. Now, for the average turnaround time, its formula is finish time minus arrival time. So P1 finish at time 8 minus its arrival time of 0. P2 finish at time 12 minus its arrival time of 3. P3 finish at time 17 minus its arrival time of 4. P4 finish at time 20 minus its arrival time of 6. P5 finish at time 22 minus its arrival time of 10. 8 minus 0 is equals to 8. 12 minus 3 is equals to 9. 17 minus 4 is equals to 13. 20 minus 6 is equals to 14. 22 minus 10 is equals to 12. For its total of 56 divided by the number of process, which is 5. So our average turnaround time is equals to 11.2. That's all. Thank you.
Everyone, I'm going to teach you the priority algorithm, preemptive version. As you can see, I've already prepared the process and the Gantt chart. Okay, since the arrival time of P1 is 0, so it will be executed first. But since the arrival time of P2 at time 3 and its priority is lower than the process number 1, so P1 will be preempted. So it will be putted on a ready queue. So P1 with the remaining time of 5 because P1 consume 3 seconds when it's executing and its priority is 4. Then P2 arrive at time 3 and first time of 4 and its priority is 3. So since P1 are already preempted, so P2 will be executed. But as you can see, at time 4 P3 has arrived. So and it's P3 has a highest priority among all of the process. So P2 will be preempted and P3 will be arrived. So P3 has arrival time of 4, burst time of 5, and priority of 1. Then P2 has already remaining time of 3. Then its priority is 3. So since the process number 3 or P3 has highest priority, it will be executed until its burst time becomes 0. So at this point P3 will be ended. And before it ends, P4 already arrived because its arrival time is 6 and the execution time of P3 is 9. So P4 has a burst time of 3 and priority of 2. So since in our ready queue the P4 has the highest priority, it will be executed. So until its burst time has become 0. So at this point P4 has already ended. And P5 has come, has arrived because of its P4 its execution time was P4 as 12, then its arrival time is 10, so it will be arrived. So has a burst time of 2 and priority of 2. Take note when doing the priority algorithm, when there's the same priority, you will apply the FCFS or first come first serve. So P5 arrived, then it will be executed because of its highest priority, so it will be ended at time 14. So at this point ended. So P1 and P2 are the remaining process that are in ready queue. So I'm sorry, I forgot 22. Okay. So at this point, P2 has the highest priority, so it will be executed until time 17. So it will be ended. And P1 will be next to be executed. So it will be ended at time 22. Okay, now we will be compute the waiting time and turnaround time of each process. In order for us to get the average waiting time and then the average turnaround time. So we have a formula for waiting time, that's starting time minus the arrival time. So P1, since the starting time of P1 is 0 minus the arrival time of 0, then next we will look for another P1 because this is a preemptive, so we will look for the process P1. So the other P1 its starting time was 17 minus the arrival time of the finish time, or yeah, so 3. Then because of P1, other P1 was ended at time 3, so it will be here, so it will be equal to 14. Then P2, same process, so 3 minus 3 plus 14 minus 4 is equals to 10. Then for P3, 4 minus 4 is equals to 0. P4, 9 minus 6 is equals to 3. Then P5, 12 minus 10 is equals to 2. So the total of the waiting time is 29. Then we will divide it to 5 to get the average waiting time. So we will get the 5.8 ms. So here in turnaround time, we have the formula for finish time and minus the arrival time. So for P1, we look for the 22. So 22 minus 0, since 0 is arrival time of P1, so it will be 22. Then 17 for P2 minus 3 is equals to 14. Then for P3, we have 9 minus 4 equal to 5. Then P4, we have 12 minus 6 is equals to 6. And lastly, 14 minus 10 is equals to 4. So we will get a total of 51. Same process, divided by 5. Then we will get the 10.2 ms. So that's how we compute the priority algorithm preemptive. Next video we will teach you the priority algorithm non-preemptive version. So for now, thank you. So welcome back, guys. Last time I discussed to you the preemptive version of priority. Now I will discuss to you the non-preemptive version of priority algorithm. So as you can see, I've already prepared everything. The purpose is to have better discussion with you guys. So let's start. So P1 has an arrival time of 0. So P1 will be executed first. So we put P1. So start at time 0, finish at time 8. So before P1 ended, there's 3 pairs arrive in our reader queue, which is P2, P3, and P4. So we'll put the first time here for 5, 3, their priority 3, 1, 2. Okay, so at this point P1 has ended, so we will look in our ready queue. So as you can see, P3 P3 arrive, P3 has the highest priority. So take note, since this is the non-preemptive version, there will be no preemption happening in this case. So P3 so will be executed next because of its priority. So P3 here, then before, so P3 will be ended at time 13. So but before that, P5 will be arrive in our queue because of the arrival time of 10. So P5 2 and priority of 2. So at this point P3 has already ended. So remove P3, will mark it ended in our queue. So at this point we will look the process for the process that has the lower priority, highest priority. So at this point we have two processes that have the same priority. So at this point we will apply the FCFS, or the first come first serve. So at this point P4 has arrived first than the P5, so we'll put P4 here. So P4 will end at the time 16 because of 16. Then after that we'll mark it ended. So P5 here, so we start at time 16 and end of time 18. So we'll mark it ended. So lastly we have P2. So P2 has the highest lower priority, which is 3, so it will be lastly ended. So P2, put here P2, and will be executed at 4 seconds. So we will end. So P2 will end at time 22. So okay, at this point we already know that we already know the process and also their starting time and finish time. So let's compute the waiting time of each process. So we have a formula here, which is starting time minus the arrival time. So for P1 has started at time 0, then arrival time of 0, so we will get 0. So P2 has arrival time starting time of 80 minus the and arrival time of 3, so we will get here 15. P3 has starting time of 8 minus the arrival time, so 4. P4 start at time 13, then its arrival time of 6, so we get 7. So P5, so start at time 16 minus arrival time of 6, so we get 6. The total of these is the 32, so multiply it by divided by 5, so we will get 6.4 ms. So now let's compute the turnaround time. So we have a formula here, the finish time minus the arrival time. So P1 ended at time 8, then has an arrival time of 0, so we will get 8. Then P2 has an finish time of 22 and arrival time 3, so we'll get 19. P3 has finish time of 13 minus its arrival time of 4, we'll get 9. So P4 has finish time of 16 minus its arrival time of 6, so we get here 10, so 18. So for P5, finish time of it is 18 minus the arrival time of 10, we get 10. The total we get the 54 and divided by 5, so we will get the 10.8 ms. So we have the average waiting time of 6.4 and average turnaround time of 10.8. So this is how we compute the non-preemptive version of priority. So I hope you learned a lot. Then just practice well to compute even the complex priority. Process. So thank you guys.
To each and everyone, today I will teach you how to compute the average waiting time and average turnaround time
of each given process using preemptive version of SJF algorithm. At first, you need to identify which process will enter first in the ready queue. Will based on the arrival time of each process given. Since process 1 has arrived at time 0, we will put P1 in the Gantt chart with its arrival time. And we will count 8 of its burst time. But at time 3, P2 has arrived. So P1 will be preempted and P2 will go to our ready queue with the burst time of 4. And P1 has the remaining time of 5. And since P2 is in our Gantt chart, we will count each burst time. But at time 4, P3 has arrived in our ready queue with a burst time of 5. So, P2 will be preempted at time 4 with the remaining time of 3. At time 4, P3 has arrived, but P2 has lower burst time than P3, so P2 will run again. At time 6, P4 has arrived with a burst time of 3, and P2 will be preempted at time 6 with the remaining time of 1. So we have 3 processes at the ready queue, but P2 has the lowest burst time among the 3. So P2 will run again until time 7. So P2 will be ended at time 7. We have 2 processes remaining in the ready queue. The 3 processes at the ready queue, P1, P3, and P4. And P4 has the lowest burst time among the 3. So P4 will run with its burst time 3. And it will be ended at time 10. But at time 10, P5 has arrived with a burst time of 2. So since P5 has the lowest burst time among the 3, it will run till time 12 and it will be ended. Since P1 and P3 is the remaining time in the Gantt chart and the ready queue, and they have the same burst time, we will apply the first come first serve in this process. So P1 will run till time 17 and it will be ended at time 17. Then no other process remaining than P3, so it will run till time 22 and will be ended at that time. So we're finished in the Gantt chart. We will now compute for the average waiting time and the average turnaround time. The formula in average waiting time is the starting time of the process minus the arrival time. So P1 has arrived at 0 times 0 with the 0 minus 0. And arrive again at time 12. 12 at the finish time of its first run. 12 minus 3, when we get 9. And so on and so forth. And P2 arrived at time 3. So 3 minus 3 is 0. P3, 17 minus 4 is 13. And P4 arrived at time 7 minus 6. And P5, 10 minus 10 is equal to 0. So we will add each and divide it by the number of process. So we get 4.6 ms. And the average turnaround time and the formula for that average turnaround time is the finish time minus the arrival time. And P1, finish at time 17 minus the arrival time 0 is equal to 17. P2, finish at time 7 minus the arrival time 3 is equal to 4. P3, finish at time 22 minus the arrival time 4 is equal to 18. And P4, finish at time 10 minus the arrival time 6 is equal to 4. P5, finish at time 12 minus 10 is equal to 2. A total of 45 and divided by the total process and equals to 9 ms. That's all. Thank you.
So, I'm going to do the shortest job first non-preemptive algorithm. So, for example, we have 5 process. We have P1, P2, P3, P4, and P5 with arrival time of 0, 3, 5, 7, and 8, and burst time of 6, 4, 3, 5, 2. Okay. So first thing you need to do is draw a Gantt chart. So I'm going to do Gantt chart. So wait lang. We need to draw a Gantt chart. So P1 has arrival time of 0 and it has a burst time of 6. So P1 is arrived in time 0, so it has the first to execute. And then next, the finish time of P1 is 6. So take a look at the arrival time. P2 and P3 has arrived in 3 and 5. So we need to compare their burst time. The lower the burst time will execute first. So P3 has burst time of 3, so it will enter the queue and then end in 9. 6 plus 3 equals 9. So next, P3 finish at time of 9. So P4 and P5 has arrived at time 7 and 8. So we need to compare their burst time again, and P5 has a lower burst time, so that we need to execute P5 and it will end at time 11. And then next, we have 2 process in the ready queue. P2 and P4, and their burst time is 4 and 5. So P2 has the lowest burst time value, so that we need to execute P2. And P2 will end at time 15. And then at last, P4, because there's no process in the ready queue, and it will end at time 20. But in some cases, if there's same burst time, you need to do the first come first serve algorithm. And then next, I have to do their average waiting time for P1, and the formula for average waiting time is their finish time, their starting time minus arrival time. So P1 start at time 0 minus their arrival time 0 is equals to 0. Then P2 start at time 11 and its arrival time is 3 is equals to 8. P3 start at time 6 minus the arrival time of 5 is equals to 1. P4 start at time 15 and minus by 7 equals to 8. P5 start at time 9 minus 8. Then we have to compute 8, 1. We have 18. And you need to divide the total sum of average waiting time by 5. And then equals to 3.6 ms. And then next, I'm going to do their turnaround time. And formula for turnaround time is finish time minus arrival time. So the finish time of P1 is 6 minus arrival time of 0 is equals to 6. P2, the finish time of P2 is 15 minus arrival time of 3 equals to 12. And P3, the finish time of P3 is 9 minus the arrival time of 5 equals to 4. And P4, finish at time 20 minus 7 was to 13. And P5, finish at time 11 minus arrival time of 8. So we have 38. Divide the number of process, which is 5. Then the turnaround time average is 7.6 ms. So, thank you for listening.
Thank you for watching! Hope you learned a lot. Don't forget to like, comment, subscribe in the description below.